All right, so today we are looking at lesson 4-5, and we are going to learn how to solve quadratics both graphically as well as by factoring, but mostly and mainly by factoring. So let's just get the boring stuff out of the way. So where the graph of a function intersects the x-axis, which would be here and here. So these values here are called the roots or zeros. Zero or root of the function. To find the zeros of a quadratic function in this form, you're going to let the y value be 0, because if you look at these where the parabola crosses the x-axis, the y value along the x-axis is always 0. So that's why we're going to replace y with 0. And so then we always use what's called the zero product property. So you're going to take this quadratic, which originally, this one in your example, was x squared minus 2x minus 15 equals 0. So if this was your original quadratic, we let y equal 0, and then you're going to factor this. Well, it factors into these binomials. And then to solve, according to the zero product property, it's just logic reasoning. If this times this is equal to 0, then one of these two things or both must have a value of 0 for the product to be 0. So we're going to set each one of these equal to 0 to determine what would make them 0. So x minus 5 equals 0, and x plus 3 equals 0. So if you solve, you get x equals 5, and x equals negative 3. And so these values here would be where the parabola is crossing the x-axis. So in this particular example, the parabola is going to cross the x-axis at negative 3 and positive 5. Because a is positive, the parabola is going to open up. So if I had to do a quick sketch, I would put my roots here and here. And then what I would have to figure out, somewhere directly in between these is going to be my vertex. Now because a is positive, I know my parabola opens up and it's going to cross the x-axis here. Well, if I have the value of negative 3 and a positive 5, the distance between 5 and negative 3 would be 5 minus a negative 3, which is 8, divided by 2 is 4. So count 4 this way or 4 this way. 1, 2, 3, 4. Or from here, 1, 2, 3, 4. Either way, you end up here at 1. So that must mean that the axis of symmetry is right through here at 1, and somewhere along this axis of symmetry is my vertex. So I know my vertex has an x value of 1. So I could actually plug 1 in here to see where my y value is, which 1 squared is 1. Negative 2 times 1 is negative 2, so that gives me negative 1, and a negative 15 is going to be all the way down here at negative 16. So it's going to be a pretty long parabola. But if I asked you to sketch it, I wouldn't expect you to go through all that effort, but I would expect you to figure out where the x value of the vertex is, because that was pretty simple and easy, and then whether it opens up or down, and then you can just sketch it, knowing that my vertex is somewhere along that line. All right, so then you've got some steps that you must use and follow in order to solve an equation using that zero product property. So I already went through all of these steps here by going through this process with you. So let's look at example 1. I'm going to go through this example with you, and for the most part you can pretty much at that point solve it yourself, because if you're pretty fluent in factoring, this should be a pretty simple section for you. So we're going to read this problem backwards. There's no coefficient in front of here. So what factors of 12 add to give you 7? So we already know that x squared is going to get broken into x and x. And the factors of 12 that add to give me, in this case, a negative 7, would be 3 and 4. Now my 7 is negative, so both of these would have to have a negative for that to work. And so I'm going to put a minus 3 here. Oops, minus 3 here, minus 4 here. Then according to the zero product property, you're going to set x minus 3 equal to 0 and x minus 4 equal to 0. Solve, you get x equals 3 or x equals 4. So you have to pay attention as to which way somebody who's asking the question wants your answer to be. So these are the places at which the parabola is going to cross the x-axis at 3 and at 4. And so you know your vertex is somewhere in between there, so at 3.5. And we know the parabola opens up because the coefficient of x squared is positive. But they might ask you for your roots or your zeros to be in ordered pair. If that's the case, remember y is always 0 on the x-axis. So, and it says x equals 3, so that means the x value must be 3. So in ordered pair format, your answers would be this way. So just pay attention to the directions and how they want the answer to be done. All right, so what I would like you to do is to pause the video, and I want you to do A, B, and C on your own. The only thing that I will caution you at is to make sure that you have 0 on one side of the equation. And typically I will move things towards the side, right or left, of where x squared will be positive. So right here, see how x squared is positive? I would move the 9x over to here by adding its opposite. Move the 45 over here by adding its opposite to both sides. So you do have to make sure that 0 is on one side first. So okay, pause the video and do those 3, and then we'll come back and do the rest. Okay, so hopefully you have completed these 3. Try to straighten that out. All right, so for this one, you do have a greatest common factor, so you do have to factor that out first, and I can divide both of these by 8x. And so that needs to come out in front. Anytime your greatest common factor has a variable in it, you have to pull it out in front. You can't divide it and hope that it goes away, because you're going to lose one of your answers. And so then if I actually divide that out, the 8's cancel. X squared divided by x is x. Negative 16 divided by 8 is negative 2, and the x's cancel. According to the zero product property, we have to set each of these equal to 0 and solve. There actually is an answer to this one. This is the one that most kids tend to get wrong if they're going to get one of them wrong. 0 divided by 8 is 0. Anytime you have a monomial means one term, 100% of the time the variable's value is going to be 0. All right, so then on this one you're going to add 2. And for these easy monomial or these easy binomials, I'm not going to always show you the work. I just did on this one because I showed you the work on the other one. So there we go. All right, so let's look at B. So for B, we have to move the 9x to the side where x squared is positive, because that makes it easiest to factor. So then we are looking for factors of 18 that add to give us 9. So I'm looking for factors of 18 that add to give me a negative 9. So that would have to be 3 and 6. So 3 and 6 add to give you 9. Your 9 is negative, so both of these are going to have to be negative. So that gives you x minus 3, x minus 6 is equal to 0. Then if you set each one of those equal to 0, x is going to equal 3 or positive 6. And then let's look at C. So we have to move the 45, so I'm going to subtract that first. And so we're working with the equation of 20x squared minus 45 is equal to 0. So this time, they don't both have an x in common. They do have a 5 at most in common. So you have a couple of choices. Because the GCF is just a 5 and no variable, you could actually divide it all the way through to the other side and let it disappear. So you could go and divide it over here and just say that you've got 4x squared minus 9 equals 0. 4x squared minus 9 equals 0. However, if you chose not to divide it all the way through to both sides, and you do like we did on the example A, so I'm going to erase this from here. So let's say that you chose not to divide it to both sides, you just wanted to move it out in front. So then you would have this with a 5 out in front. The 5 is not going to create a 0 here because the 5 is 5. There's nothing being multiplied it that's going to change it from being a 5. So because there's no variable associated with it, we would not ever set this equal to 0. But this can be factored further because it's the difference of two perfect squares. So the 5 will stay a 5, but we have the plus minus pattern of the difference of two squares. So the square root of 4x squared is 2x, and the square root of 9 is 3. So then the only ones that you're going to set equal to 0 would be 2x plus 3 will be equal to 0, and 2x minus 3 is equal to 0. So then 2x is equal to negative 3, and then divide by 2, x is equal to negative 3 halves. Add 3, 2x is equal to 3. Divide by 2, x is equal to positive 3 halves. So the next question talks about using the table feature on your calculator to find the zeros. So before we do that, let's just talk about why. So I'm going to draw just a sketch of a parabola in here. And then these would be where my zeros are. So this is why the table works the way it does. So as we move from the left to the right, the parabola is going up, down, down, back up again. So to the left of this 0, the y values here are positive. In other words, all of these to the left. So if I chose an x value over here, it's going to be, the y value is going to be somewhere up here. So the y value to the left of the 0 is negative. But as soon as we reach these 0 and cross the x-axis, and we go down here and we're moving from here to here on the x-axis, all the y values down here are negative. So as soon as we cross that 0, all of a sudden the value of y changes. And then as we move to the other side from here and we hit this 0 again, all of a sudden the y values are back to being positive again. So the point of this is every time we choose a value for x, we are looking for a change in y to show us that a 0 has occurred, because every time y goes from positive to negative, we must have crossed the x-axis. Or from negative to positive, we must have crossed the x-axis, because that's when the y value changes from negative to positive. So what you're going to do, so I'm going to erase all this. All right, so I know that we like to move everything to where x squared would be positive, but in this case it doesn't matter because you're going to use your calculator. So because most of the terms are over here, I'm going to move the negative 2 to the left, because we have to have 0 on one side, or in this case we're going to let it be y, but we're going to add 2 and add 2. So we end up with negative 2x squared plus the 3x, and then plus that 2. Normally it'd be equal to 0, but we're going to let it equal to y, because you're going to put that into the y equals in your calculator, your TI calculator. So go to the y equals button, and you're going to put exactly what you see here into that part of your calculator. So let me get that in my calculator. And then you're going to hit enter, and then you should be able to graph it. If for some reason you're not in the standard viewing window, you should notice. So if you're not in the standard viewing window, just go to, I want you to go to, wait, let me just quit what I just did. I have no idea what I just did on my table. So you want to go to Zoom Standard. So if you hit the Zoom button, which is one of those gray buttons at the top of your calculator, and you hit Standard, which is number 6, it'll straighten out your viewing window. So you have a parabola that opens down. So currently, I'm just going to sketch what it looks like. So in my table, or in my graph, it looks like it's doing this, give or take. All right, so it looks like the vertex is somewhere around here, which is somewhere between 0 and 1 in that kind of area. So what I want you to do is you're going to put in -2, -1, 0, 1, and 2. And we're going to kind of determine, based upon sign changes in y, where a 0 might occur. So you're trying to find both of them. So if you go into, if you do second graph will bring you to your table. If for some reason you cannot input values for x into your table, you'll need to go to second table set and make sure that the independent variable is reading ask. If it's not, scroll over to ask and hit enter, and then go back into second graph, and you'll bring you back to an empty table. And then you need to put in these values. So if I put -2 in, it will spit out the value of -12. And if I input -1, the calculator will spit out -3. So far there's no sign change. From -2 to -1, there is no 0 because y did not have a sign change. Then I'm going to put in 0, and all of a sudden I got a +2. So what that means is somewhere between here is a 0, because I got a sign change in my y. All right, so we'll further explore that in a moment. Then let's go and put in 1. So if I put in 1, I get a 3. So no sign change from 2 to 3, so there's no 0 between 0 and 1. And then finally I'm going to put in 2, and lo and behold, I got a 0. So if my y value is a 0, this is actually, I just was lucky and found the actual 0. So that's an actual 0. So that was pure by luck. If I hadn't gotten another sign change, I would just keep choosing integers after 2 until I got a sign change in y. So let's go back to here, because we've found 1 0. So here's 1 0 right here. The other 0 is somewhere between 0 and -1. What value is directly in between 0 and -1? That doesn't mean it's always going to be it, but I'm going to kind of choose that. And I'm going to just guess and hope that it's -1. I won't ever make you do this without an exact calculator, but I'd be happy if you said there's a 0 somewhere between 0 and -1. And then here you can tell for sure that, oh, there's a definite 0 at 2. So let's plug in the value -1/2. So -1 divided by 2. And we happen to get a 0. So again, that was by luck. So this is the other 0 that we're looking for. So our answers would be x equals -1/2 is one of our zeros, and 2. So then you try that with B. So B has a little bit more work to do to get it into the calculator. So you're going to have to move the 4 and the -x over to here, and then you can put that value in the calculator and do some guessing and checking. Okay, so for this problem, we're going to have to move everything over to the left. So I'm going to subtract 4 and add x. And so that gives us 4x squared minus 13x plus 3 equals y. And so I'm going to throw that into my y equals. Okay, so then we're going to hit our second table, and actually our ordered pairs from before are there. And so you could use, or x values from our previous problem are there. So you could try to use some of those. But if you look at your graph, if you just hit graph, you can just look at the graph of the parabola that the calculator is giving you. It's going to look like this. So it almost looks like part of the parabola is going through or very close to 0. So I think I'm going to start with -1 and go 0, 1, 2, and 3 on my table of values. And -1, whoops, I have to put in the correct value, would be handy. So -1 gives me a value of 20. And if I plug 0 in, I get a value of 3. So far, no sign change. I put 1 in, I get a value of -6. So all of a sudden, there's a sign change from here to here. So I know there has to be a 0 somewhere between 0 and 1. And then I'm going to put in 2, and I get -7, so no sign change from -6. And then 3, I get 0, and that happens to be a 0. Because y is 0, so therefore it's an exact 0. So I found one of them. So then if you play around here and just start looking for something really close to 0, you can plug in, I don't know, 1/2, -1/2, -1/4. I just happen to know it's -1/4. So if I put in -0.25, I didn't mean negative, I want a positive. Because there you go. What was I thinking? I'm in the wrong spot. So I want to be between 0 and 1, so that would definitely be positive 1/4. So that's where I get my 0. So then here's your other 0, but then again, that's a whole bunch of guessing and checking. So my answers are x equals 1/4 and 3. But at the most, I'm going to ask you, okay, between what two integers? And I would just expect you to say between 0 and 1, and then you found the 0 at 3. All right, so in this section, we are going to use the 0 feature of the calculator. So this is much better than our guessing and checking with our table of values. And so you're going to go ahead and put this into the y equals to clear out what's there. And hit enter, and then you're going to hit graph. And so you should see your graph, and in this case, our graph looks like this. It's quite wide and fat. More of it's over to the left. And then we're going to find out where the graph crosses the x-axis by using the following. So you're going to go ahead and do second calc. So I'm going to write these out for you. So your first step is second calc. And then on that menu, you have a whole bunch of choices: value, 0, minimum, maximum, intersect, and then some other ones that make no sense to you. And so because we want to find a root or a 0, then you are going to click on the one that says 0. And so you can either scroll down or just hit 2, and it's going to come up with a question. Left bound? Well, you need to move your cursor, so you may or may not see your cursor, however you want to pronounce it, but you need to move your cursor so it's over here. We need to the left of this 0. So use your toggle button, which is that big gray button in the upper right part of your calculator. Use your toggle button to toggle right and left, not up and down, but right and left until you get it over here. So I'm going to toggle, and you can see the x value changing to a negative value, And then you'll all of a sudden start to see kind of like a little spider looking thing coming through, and I'm going to place my toggle right about here. And so on left bound, I'm going to hit enter, and then it asks you right bound. So then you need to move where it currently at is here, use your right button and move it down below or to the right of the 0, because this is to the right of the 0. So use your toggle till you get down below and hit enter. And so when I did that, it's now down here. And then the third question says guess. Well, now your calculator knows that you're looking for a 0 from here to here, and it's using the fact that it knows y has changed from a positive to a negative to narrow down exactly where the x value of that 0 is. And so all you want to do is hit enter, and it comes up with a 0 being, it says x is -6, whoops, I want blue, x is -6, and y is 0. So that's one of our zeros. Then I want you to try to find this 0 on your own. So it's going to ask for left bound. Well, this time your left bound is down here and your right bound is up here. So try it on your own. So pause the video. Okay, so when you toggled and hit left bound, right bound, and guess, it should have told you that your x value is 4 and your y value is 0. So what I want you to do is I want you to try that same thing in B and C. So remember in B, in order to put this 1/2 into your y equals, it has to go in parentheses. And then for your C, you shouldn't have any problems at all. And also for B, don't forget that you need to move this over to the left. This side needs to be 0 or y. All right, so go ahead and pause the video. Okay, so this is what your solution should look like. You should have subtracted 6 from both sides, which gives you this. I put this into the y equals, and this is about what the sketch looks like on the viewing screen of your calculator. And so when you go to second calc and choose 0, your left bound should be here, right bound should be here, and then you hit guess, and you should have come out with a decimal, -2.60. I rounded to the first decimal place. Then to get this 0, your left bound should have been down here, right bound up here, and then you hit guess, and you get 4.6, 0. So now try C, now that you're an old hat. So pause the video and see how we do. Okay, so this is what the graph should look like if you put this into y equals. So make sure you're clearing out the previous problem before you put the new problem in. And then this should be left bound, this should be right bound, and if when you hit guess it says error or something of that nature, you probably had your left and right bound in the wrong spots, because it's trying to narrow it into this much of a window to try to find that 0. And over here, this is left bound and this is right bound, and so these are the zeros that you should have. All right, so then let's look at this word problem. Straighten it up, make it smaller. All right, so here we go. Hang on, let me get rid of something that's just up there. We're still trying to straighten this out. Boop, there we go. Okay, so the height in feet of a ball thrown by a child is represented by this, where x is the horizontal distance in feet, so horizontal is this way, when the ball is thrown. So I like to draw a picture. So let's draw a picture. Here's grass. Here's a child. I only do stick figures. So here's a child, and this child is throwing a ball. Let's call it a blue ball. And it wants to know the height in feet of the ball thrown by a child. So this ball is going to get thrown something like this. So this is the horizontal distance from here to here, but you can see that the path that the ball takes is a parabolic arch. So it's in the shape of a parabola. And this is representing the height at any point in time. So as time goes on, so the seconds, the ball reaches certain various heights. So over a certain amount of time, so x is your time, then the height is in feet in this case. So how high is the ball when it leaves the child's hand? So this right here is not at the ground. So ground here would be 0. So if that ground is 0, this is 0 feet right here. We have to figure out the height from here to here because they haven't said, oh, the child's hand is 4 feet from the ground. So you have to figure that out. So when you start to throw the ball, that is time 0. So right here where this child's throwing the ball, t, or in this case x, I guess I'll use x. Since they're using x, they oftentimes use t for these problems. So x is equal to 0 because that's time 0. And then by the time the ball is released and hits the ground, because gravity is going to pull it to the ground, that's going to be another time. And so the amount of time that the ball was in the air would be from time 0 to here. So they want to know how high was it when it left the child's hand. So we're going to plug in 0 for time here and see what we get. So we're going to plug in f of 0. We have -1/2 times x squared plus 2 times x plus 3. And so wherever there's an x, I'm putting in a 0. So this value would be 0. 0 squared is 0 times -1/2 is 0. This is 0. Added together we have 0, so we're really left with 3. So f of 0 is equal to 3. So therefore, the ball is 3 feet from the ground. All right, so then the next question is asking, what is the maximum height? Well, key word here is maximum. So maximum and a minimum on a problem means the vertex. So what they're asking for is, where is this maximum height right there? So you just have to find the vertex. So put this into your calculator. And so you're going to put it into y equals into your calculator, or you could do the opposite of b over 2a. So you could either put it in your calculator or do that. So let's go ahead and throw it in our calculator. So we've got the x value of the vertex is the opposite of b over 2a. And in our case here, a is equal to -1/2 and b is equal to 2 because those are the coefficients of the x squared and the x term. And so I'm going to throw those in here. And so the -1/2 goes down here, and then the 2 goes up here, and we end up with -2 over -1, which is +2. So the x value of the vertex is 2, which means it reaches its maximum height at 2 seconds, but it wants to know how high it is. So that represents the time. So then we're going to have to put that into the function. So we're going to find f of 2. So -1/2 times, we're going to put 2 into here, and then 2 squared is 4, half of 4 is 2 times a negative, so that's -2, plus 4 plus 3, so f of 2 is equal to 5. So that would be 5 feet. So therefore, the ball, or the maximum, the max height of the ball is 5 feet. All right, and then the last part of this problem, how far from the child does the ball strike the ground? So we want to know this distance from here to here. So if I want to find this distance from here to here, I know that that's normally time. But if I look at this as if it's in the coordinate grid system, and I know that the height here, so let maybe, oh, if this is 0, 3 here, so this is 0, 3 here, that's a 3, and this is 2, 5 here, then we have to figure out this ordered pair down here, and I know that the x value here is 0 to here. That's going to give you this distance here. In my honest opinion, it doesn't necessarily, this should just be time. It doesn't necessarily give you a distance, but we could reason our way through that from here to here is going to give us that same distance as it would be from here to here. So let's go ahead and find this ordered pair and see what it is. And so again, that height is at 0. And so if that's height at 0, this is going to be considered the x-axis right here, and that's going to be a root. It's going to be where it crosses the x-axis. So we're going to put this in our calculator, and we're going to find a 0. So we're going to put in our y equals if you haven't already. So give me a minute to throw it in there. And then you're going to graph it, and it's going to look exactly like the picture that you see here, and it's opening down, only this is the y-intercept, and this is where it's hitting the x-axis. So if you go to second calc 0, we're only interested in the right 0. So right bound would be above, I'm sorry, left bound would be above the 0, and right bound would be below the 0. And if you hit guess, you are going to get a value of 5.16, 0. And so the distance from here to here, I disagree with the question because from here to here is telling you time, but Miss Jean Adams wants to convert this to distance, but really this question should say how long did it take for the ball to strike the ground, because that's really what x is telling you. So I'm changing that because I really have a foundational issue with that question. So how long did it take for the ball to strike the ground? I feel so much better now. All right, so since we went from time 0 to 5.16, therefore, it will take 5.16 seconds. I'm assuming this is in seconds. She didn't say otherwise. It will take 5.1 seconds for the ball to hit the ground. If it's minutes, boy, that's quite some child with an arm, I'll say. All right, let's look at our last page. So on this page, we have a couple of more word problems. So for the first one, I'm going to make it a smidge bit bigger. We're still talking about another question. So if you want to, pause the video. If not, you could watch me walk you through it. But I'm real big about drawing a picture. So this particular one says, when serving in tennis, a player tosses the tennis ball vertically in the air. Now that typically is a very straight line up and a straight line that comes down. So it's a very skinny parabola that goes up and comes down and opens down. And so you can see this right here. Now, the height is measured in meters from the point of the toss. So they're considering the point of the toss to be ground 0. Well, clearly tennis players don't throw a ball from their toes, but they're making an adjustment here. So if we were to draw a picture, here's what's going on. Here's your tennis player. Here's the net right there, and here's your player. Back here, tossing a ball. Here's the ball, and he's going to toss it straight up, and it's going to come straight back down. And hopefully he hits it before it hits the ground. Well, what they're saying is right here, this is times 0. So the x-axis is going to be right through here. This is considered the x-axis. This is height of 0. Okay? So the question is, how high in the air does the ball go? Well, that would be way up here. Isn't that a maximum? So you're going to throw this into your calculator, into the y equals, to clear out what was there before. And instead of t, you're going to use x. So instead of negative 5t squared, put in negative 5x squared. And then plus 7x. And you graph it and you get this nice skinny little parabola. And all you want to do is find the maximum. So if you go to second calc, so I'm going to write this down. So second calc, again, you have menu options, and 2 of your menu options are minimum and maximum. Well, you want to choose maximum. So it's a little similar to doing your roots, because it's going to ask you left bound and right bound. So when you choose maximum, and if you choose the wrong one, it's going to tell you it's an error because it can't find the max or min, whichever one it's not. So you'll know. So your first question is left bound. You want to come close to where the vertex is, but not on the vertex and not super close to it. So, you know, be in the general direction. So hit enter, and then toggle to the right of your vertex, hit enter, and then it says guess, and so you want to hit enter again, just like we did with the zeros. And so then it gives you the value of 0.699, and the 9 like continues to repeat, and you have a couple of other numbers, and then you have 2.45 for y. Well, we're interested in the maximum. So we're interested in the maximum, which would be the y value of your ordered pair. So we really don't care about that value. That's your x value. And so therefore, the ball went 2.45, and they said that this was in meters high. So that's it. So then look at the next question. So for this question, assume that the player hits the ball on its way down when it's 0.6 meters above the point of the toss. So let's move this down a little bit so we can see the picture. So they're wanting you to say that it's 0.6 above here. That's when they hit it. And that makes sense because they're going to hit it like this, right? So assume the player hits the ball on its way down when it's 0.6 meters above the point of the toss. For how many seconds is the ball in the air between the toss and the serve? So the player hits the ball on the way down. So from the toss to the serve. So it goes up here and then it's going to hit here. So let's assume, for chuckle's sake, that this, I'm going to put a, well, let's put a blue line. I'm going to put a blue line here that would represent 0.6. And that's in meters. So we want to figure out what, and it says for how many seconds. So that's how many seconds is your x value. The ball is in the air between the toss and the serve. So the toss is height of 0. And we want to go all the way up until we hit here. So if we find this ordered pair here, the x value started at 0 here, and then whatever the x value is here, that should tell us what that value is. So we're just going to put 0.6 in and see what values we get. So go into your table of value, or go into your y equals. In order to get both of these values, you're going to have to put in to y sub 1, you already should have put in negative 5x squared plus 7x. So you already should have put that into y sub 1. In y sub 2, This is a horizontal line going through, it would hit the y-axis at 0.6. So that would be y equals 0.6. So in this y sub 2, we're going to put in 0.6, and it's going to create this horizontal line. So go ahead and put that into y sub 2 and hit enter, and then hit graph. So then what you're looking at, you could zoom in if you want to, but currently you have in your viewing calculator this, the 0.6 that I'm going to blow this, basically I'm giving you a blown up version, but this is that one right there. And the parabola that we graphed earlier is going to look like this. Right here. So this is the actual 0 if you calculated 0 on the calculator, but we want this right here because this was the toss, and then the ball went straight up and came down, and this is where he hit the serve. So we've got to find where this line intersects with this line. So we're going to actually use the intersect feature. So you're going to do second calc, but this time we're going to use intersect because I've got two equations that I have put into my calculator. I put in these two equations, and these are the two lines, the blue line and the red line, and I want to know where they intersect here. They also intersect here, but I want to be over here. So when you go into second calc and you scroll down or hit 5 for intersect, make sure that the first curve is not down here, that you toggle it to the right until it moves closer to this intersection but not on it. So I would toggle until you had something here. So that's what I'm going to do, is toggle to the right. All right, and then hit enter. And then it's going to go down to the second line, and it's going to move it somewhere around here. Just move it to the left a little bit so it's just off of that intersection just a smidge, like to right there. So I'm just going to move it one little click and hit enter, and it'll say guess, and you hit enter again, and it gives you the value of 1.3. I'm just going to round to one place, comma 0.6. Well, we are interested in the x value because x value is time right here. So that's the one that we're going to use to answer the question. So it must have taken 1.3 seconds to go from this point of toss to here. And so, therefore, it took 1.3 seconds to hit the ball. Wasn't that fun? Now go forth and be merry on your homework.